is that you can create test cases to understand a library. So we know that string is available to us from the base class library, and if you want to test if string functionality actually work, you can go ahead and start writing test cases. String should give string gives length, and then once again we're going to go in the arrange, act, and assert mode. And in the arrange part, I'm going to say var say input assigned to new string, and I'm going to pass say hello. Right now, the act part probably is not needed in this case, but we can assert that the input dot length is say 5. Right. It is going to complain. It's going to say that you flip the order. So let's go ahead and change that order. Swap arguments. It likes the hard-coded values to be the first member and the calculated value on the right hand side. We can go ahead and be a little picky about it and say that this is the length, and do input dot length part here, and then validate, or let me just change this to actual length, and I can put the actual length member over here. So through this we have verified a library called string using a test case. If you want to evaluate some library, you can go on writing more difficult test cases and verify the scenario once again with inline data. So if I change this and start accepting input here as string, right, and probably once again the expected length, then we have an entire code and application that is going to validate different type of input for us, right? And then before you start using say string inside your application, you will have a very good use case of how strings are built. You can go on testing different type of functionalities. I'm just going to copy and paste, Control E, Control V. It duplicates the code, and this time I'm going to say to lower uh, lowers the case of input string. And there are multiple ways we can test this, like hello should look like this, and this should look like hello world double quotes, and instead of the, I'm just going to change it to expected, and over here instead of doing like one single assertion, uh, we'll have to run a for loop of assertion. And then this is where the assert statement, they don't read like English language. I mean, this code is fine. Expected. Okay, let me change this for to a for each, and I'm going to get rid of this, and instead of collection I can replace it with expected, and to compare this expected with these values here. Okay, I'm so sorry. Let's go back to this, and I'm going to say expected dot length, and now we'll have to compare char.to lower, and we're going to take the input string and pass it the index equal to we're going to take the expected string, or I'm so sorry, the act part is going to look a little different. Now I'm going to say actual here, and input dot to lower. Now we're going to compare not the input, the actual of I with expected y, right? And probably we're not going to do it inside an assert. We're going to do we're not going to do inside if. We're going to use some assert overload, assert dot equal, and let's see if there is an overload for character, right? The expected, the actual will have to rely on this and pass the actual I and the expected I. Once again, I have flipped the order. I would rather have them at their correct spots. I'm going to comment this code out, right? And then let's do another round of walkthrough. So we have repeated a test case. We want to validate the to-lower functionality available on the string class, right? The way we're going to do this, the arrangement part, because we are using a theory and we have a lot of inline data, we have moved the arrangement part uh, to the function parameters. And there could be more arranged statement, but we don't need anything in our test case right now, so we're going to leave it empty. In the actual thing, in the act section, we are going to call the to-lower function on the input and get the actual result of to-lower functionality. Now, we're going to run a for loop where we are going to compare the actual with the expected. The expected is hard-coded to the expected result, and then we are going to compare that this index and this index, they are equal. Right? This thing eventually is going to pass. Let's just go ahead and run this test case. Right? And so I'm not sure where the result is coming for this, but then it is saying that these two test cases, they're both passed. I wanted to execute a single test case. And then this is where our string shift test cases are written. Because of those two input parameters, we're going to see two test cases. And if we now expand it and see the input and the expected input, they're both passing. Means that the to-lower functionality of the string class is working the way we expected it. The only thing that I don't like in this code is that these assert statements, they're not very friendly. They don't read like the English language. And putting in loops like this, I'm not a big fan of this either. So we're going to switch, and I'm going to show you a framework which makes the assert statements a lot more friendly. So I'm going to search for Fluent assertion, and look at the solution here with almost 100 million downloads. I'm going to add it to our test project. Right. With this project added, we're going to see Fluent assertions over here in the packages. Let's close out of these. Right, and I'm going to add a using statement using Fluent assertions. Now, let's bring up Visual Studio, Google Chrome. Right, I'm going to say Fluent assertion cheat sheet, and let's look at this step. So the way we were writing assert, it is going to change a little. On the actual result that we receive, we're going to call a function called should, and on should we're going to get a different option like don't be empty, or you be empty, or you be false, or you be true, or probably it contains something, right? Then we can check for collections that it does not contain a specific item, or it only contains that one item. So there are multiple options, and then I like the syntax of how Fluent assertion is Let's go to documentation. Our Fluent assertion is giving us um, English-like um, English-like field. So like actual is the value, then we are calling our should function, and starts with AB and ends with high and contains EF and has a length of 9. Right? So let's go ahead and start making those changes in our application. So instead of assert or equal, I'm going to say the actual length should dot be, and then I can pass the expected length here. Right? Now read this piece of code here in comparison to this assert statement. So assert dot equal, and we are passing two parameters. This is more like programming, but then this statement here, actual dot length, actual length should be expected length, right? Much better. Then we can modify this for loop to be actual dot should be, and then I pass the expected string. Make sense? So then actual and expected, they should match. Let's write a test case for some collection. So I'm going to write public void collection, and just to make it a test case, we'll have to modify it with a fact if we don't want to provide any set of data, right? And now if I define a collection could be an enumerable or some input value. I'm just going to say collection here, and I can say new set of integers like so, and then pass 1, 3, 5, 7, and 9. So this is the arrange part. In the act part, let's assume that you have some function which is going to square all of these numbers, right? So that function I can write in line alongside this test case, and we're going to use the lambda expression. Over here I'm going to say dot collection dot select, and select will have to include the system.linQ assembly. So with that added, now if I do x into x, we're going to get a new collection with square values in it. Now if I want to validate that all these numbers are square, I'll have to create a new collection, call it expected result, and assign it to 1 and 9, 25, 49, and 81. Right? I'm going to compare this square collection or the actual result with the expected result, and because there are multiple scenarios possible, we are going to start with actual result should, and then the first thing that I'm going to check is that it is not empty, right? You can keep repeating these statements like should and have count of 5 elements, because we know that there are 5 elements that we are providing as input. But rather than repeating all this, Fluent assertion, if you hover over the return types, let me go ahead and hit F12, it is returning generic collection assertion. And from this point onward, if you look at these objects, they are returning an AND constraint. Right? There are other constraints that are also available, I guess. Right. So this AND constraint is going to give you an option of uh, chaining these functionalities together. So with AND, I can delete this piece of code here and see actual result should not be empty and have count of 5. Make sense? And if you want to chain other functionalities, you can go ahead and do that here. Let's go ahead and make this a little neat. I'm going to say dot and then dot. We are expecting a couple of results in order. So we can say contain in order, and now we can pass the expected result object. Right. Now if I run this test case, let's go and debug this. We'll hit debug test. So this is the collection, this is the expected result. It has 5 elements, everything squared. And now if we call this function and look at the actual result, it has 5 elements as well, 1, 9, 25, 49, 85. And this thing is going to internally iterate over the actual result and compare each element with this particular collection statement. And our test case have definitely passed here. So it took 31 seconds because of the debugging, but the test case has actually passed. There are multiple other options that are available. Like, let me go ahead and paste it from here. So the collection, or probably you can change it to the actual result, and then a couple of lines of should have count greater than 3. Right? Just to show you that there are other overloads available. Have count greater than 3, have count greater or equal to 4, have count less or equal to 4, 5 not have count, have the same count as this collection here. So once again I can replace this with expected result over here and not have same count as then any other value. So there are multiple overloads that are available. If you go to the definition of this file here and scroll through this, they are categorized under uh, multiple classes like self-referencing, collection, assertion. So this thing is only going to deal with collections, but you have options for enum and exceptions. So let's go ahead and take an example of exception. Inside link queue, we'll copy this. I'm going to call it link queue tests. Alright, so link queue has an overload or a function that selects a single element. Right now, let's go ahead and let me make all these values the same. I'm going to say collection dot single, and single can once again take a lambda. Right. So what I'm doing is that this function here, let's go to the definition of this, and I'm going to show you a specific part of its documentation. So when an implementation throws an exception, it is generally documented in the base class library that the argument is null. But then there is another exception called invalid operation exception. No element satisfies the condition in the predicate, and more than one element satisfies the condition. Right? So single guarantees that whatever filter we are applying here, it is going to result in one and exactly one value. Alright? If it does not return any value, it is going to throw an exception. If it returns more than one value, it is going to throw an exception. And if it is empty, it is going to throw an exception. So no element sequence is empty and more than one element. The predicate is going to fail, and if it fails, it throws an exception. So I'm going to close out of this and check the first condition, that more than one element, and the single is going to throw exception. In the assert part, the question is, how do we verify that this particular function has thrown an exception? Like, the only strategy that we have is a try block, like from the regular piece of code. Excuse me. So if this thing throws an exception, our control is going to get here. I can set a breakpoint, not a 5, sorry, and hit and run debug test. Okay, I should have started probably over here. I can always pull back the yellow arrow and move this back. Because of exception, probably it's not going to let you do that. So let's stop and start again. Alright, so we are debugging the test case now. If I hit F10, it is going to define the collection, declare the collection, and the single is going to match with more than one scenarios, and that exception is going to appear over here, and it is once again going to throw. We don't want this. We want to write a test case, and we want to verify that we have received the exception. Debug test. So the collection is declared. We are running the single statement, and now we are seeing the exception of this type. So I'm looking for the exception type itself, but for that I'll have to catch the specific exception. But then if you have not returned it for the specific exception, you can always call the getType function, and getType is returning the invalid operation exception, exactly what we read here in the documentation, that it is going to return an invalid operation exception. Going back to our test case, when we have more than one element which the single filter criteria is going to pass, we want to validate that invalid operation exception is being thrown, but we can't do it this way. So there is another overload. It is also available in the assert class, but we are going to see the example using the Fluent operation, and over here we are going to define a lambda expression. Right? I don't know if lambda can be defined with the var keyword, but then I'm going to call it action, and this action, if you remember the syntax of lambda, is going to look like this. Right? It is giving an error, cannot assign lambda expression to an implicitly typed variable. So I'll have to change this to action, an action that does not take any parameter, and actions by default are void. So this function definition is perfectly alright without a return statement. Inside this lambda, we are going to execute our operation collection.single. Right? This is just pointing to that action, that when you invoke action, let me show it to you. So this is just the declaration of that data, but then the actual call is only going to happen when I put parentheses around this variable name, this action variable name, and invoke it. Right? The exception will not be thrown at line number 78. It'll be on the next line. Right? So, right, that's it. At 10, collection is declared. This has only defined the lambda, and then to invoke the lambda, right, it is going and executing this line here, but then the execution only happened after we hit this line. Right? And we are seeing a friendly message, invalid operation exception. Right? So to test if your function is throwing an exception, there's an overload available on the action class. And then forgot should, and then throw. I can do throw or throw exactly, because we know that the type of the exception. We're going to pass that over here, invalid operation exception. And then inside this, we are going to, right, so this is going to invoke this action method, throw exactly, and then it is going to catch it, and if everything goes through fine, it is going to, the test case is going to pass. So I'm going to remove the breakpoint and simply run the test. I should have renamed this class. Okay, this is still a link test. So the link test has passed. If we change the type to, just one second, for it is, alright, so because it is throw exactly, it is taking the exception. I was checking if there is in or out keyword mentioned here. That would have made things a little complicated. If I change this to exception, and now if I run the test, the test case has failed. And if we check the reason, it's going to say the expected type to be was system.exception, but then we found invalid operation exception. So the type of exception that we were expecting, it did not match with the expected type, and it is also giving us these tag trees. Somewhere down here we're going to see a func of 1. Alright, so it all started with throw exactly, and this throw exactly, it invokes this particular parameter. This style of programming, where you start with the object name and then you start calling functions on it, is Fluent APIs. Right? And then if you remember the library name itself is Fluent Assertions. So it has applied a lot of static, it has created a lot of static functions, the extension methods, and these extension methods, they are helping us write a better readable code. Let me go ahead and pull this over here. So there are multiple assertions possible. If you go to the documentation, it starts with simple assertion, basic assertions, right? And then it is comparing, say, one integer 5, 5 should be 10, and this is going to fail. The actual should be expected. These are simple examples. Then there are overloads available for string. It will give you overloads like length, and it is not empty, and a couple, like it has null or white spaces. You can read through this documentation, and there are hundreds of overloads available just for string validation. Right? You can also do regular expression validation. Right? So this is match is probably regular expression. If you read through the documentation, for instance, match equivalent of, it is this is once again going to give you that same option. It is going to do case insensitive comparison. And then there's match regular expression as a separate overload. So that probably this is only going to validate the pattern. Probably asterisk stand for any number of characters. Then dictionaries collections, they are almost the same. There are overloads for date and time, that you can define the March itself as method. So 1st of March 2010 at, so at probably is time, and this is 10:15 in the evening, and it's going to give you the local time. Right, so this is a complex looking syntax, but then I like how it reads, the program itself reads like the English language, like 1st March 2010 and 10 in the evening. Right? And then you can compare it to different date times. Right? You can compare if it is, the event is before or after is the same date. You can probably have other overloads for time as well. It is doing for day, month, year, hour, minute, second. Right? So be close to, it is giving you a window of 2 seconds. Right? Probably this is going to give you a window of 1 hour, and it is going to say that before 1 hour it is not allowed. We can apply these conditions in scenarios where, say, there is an assignment to be submitted by the students, but then the teacher only opens window for 2 hours, say after 2 weeks, and you will have to be in that window for 1 hour, 2 hours, where that link is going to be active, open, and you accept the assignment. Right. So, and we already saw example of exception. We have seen that you can invoke, and then you look for throw, and you can specify a type here. We saw this example where there was something called throw exactly, and then you can check for inner exception. So exception have a property called inner exception. If you are expecting this exception to have some inner exception, you can chain throws with inner exception, and it is going to validate all the inside exceptions as well. Right? So very handy library with a lot of options, and the code that you come up with is very readable. Then I know we have not seen events, not the one with property change or I notify property change event. It is more specific to WPF. But then if there is an event, if you remember from the delegate and event section, if there is an event that is going to get raised, you can capture those events using this property here. Then assembly references. I don't know what this is. This probably is going to help you pick up an assembly and then check if that assembly is referencing another assembly. This is going to probably save you from some form of. Okay, so when you do dependency injection and write statements like, so we have written statements like services dot add service, and then we provide generally an interface here, say IDB context, and the concrete implementation SQLDB context. Uh, if SQLDB context is supposed to have a couple of references, and there are specific using statement that needs to be added, DI frameworks, they won't generally have an idea of how things are going to get wired up and how they are going to resolve these dependencies. And then one nice way to ensure that nobody is forgetting to add right references in these assemblies, you can go ahead and um, use validation checks like this. Right? So each assembly is going to have a set of dependent assemblies that must be added. You can implement it using this particular overload. And there's execution time. So this is going to track. So there are two type of requirements that you're going to receive. Um, they are like functional requirements and non-functional requirement. A functional requirement is specifically going to tell you what the functionality is expected to do. Like a string is supposed to do case insensitive search. Right? This is a functional requirement and it can be implemented in code. But some requirements would be like the find functionality should finish in less than half a millisecond in half a second. Right? In such scenarios, if you want to implement, say, performance testing of the application, you can use these overloads here, like so execution time off, and then you write the system under test dot find, and then it comes back once again with should statement is less than or equal to 500 milliseconds. So performance testing can be done at the developer level using statements like these. So let's go ahead and write one of these test cases, and I'm going to say action dot execution time, and then over here I'm not sure if it takes an empty argument. It does not. So we're going to simply write another action here. I think there is an overload available which does task dot delay. I might have to add task library, and inside delay I can say 300 millisecond, right? And for milliseconds you might have to add another extension. Okay, so with this statement added, this underscore here means nothing. It is okay, so it takes a parameter If you have no plans of using parameter, generally you're going to get a green squiggly under the name. I don't know if, okay, so there's the one doesn't appear here, but if I declare a variable, assign it a value, and don't do anything, compiler is going to complain with a green squiggly line under the name and saying that this variable is not used anywhere. If you have a variable that you don't plan to use, you can, if not this one, but then inside lambdas and function parameters, if you put an underscore, it won't complain. So you can take a parameter like integer underscore, and it is just going to ignore that parameter. Okay, so underscore ignoring the parameter, and we are only doing task.delay. I am not sure if we need a dot wait statement here, but then let's go ahead and add that. And to check that if it requires an async method, number one indication that it would have async keyword mentioned here, and this expression here is also going to take an async parameter. So because that is not happening, that wait is redundant. I can get rid of it, and when this function completes, a 300-second delay would be over, and this test case is going to pass because 300 is less than 500. I'm going to comment this code out and run this test, and the test case hopefully will pass. Alright, so it has passed. It indicated that it ran in 9 milliseconds, which is less than 300 milliseconds. Let's go ahead and I'm not sure why did that happen. Let's go ahead and pump this number up. Let me put a wait statement first and run the test case again. And the LenQ expression, this time it took 313 milliseconds. So I think that wait statement eventually was needed. Before that, it completed in 9 milliseconds something. Now let's go ahead and bump this up to 1000, which is 1 second. And I'm going to run the test. Right, and then it says that it took 708 seconds because after 500 milliseconds, I think the test case decided to fail, and because of that, it did not reach the entire 1 second. And it is saying that execution of this statement should be less than or equal to half a second. Make sense? So if you have specific requirements that a particular API or some call should finish sooner, you can go ahead and start using these overloads in your test cases, and they're going to ensure if there is a functionality that is taking longer than expected. All right, so that is some pieces of testing that we could not cover yesterday and Fluent assertion for you guys.